Okay, so if this is -2 for x, h minus 2 will be equal to 1. Can you see that there? This is 1, 2, 3, 4, 5. So h minus 2 must equal 1 from your y-axis. Okay, and you do the same for these ones. But when you get to b, find the values of x for which hx equals 3. So look at your graph again. hx equals 3. So that means we look here, along there. So hx equals 3. So what value of x, because this is equal to y, isn't it? Y equals hx. So what value of x will give a y value of 3? This is 3 here. So if you come across, you'll have this number, but you'll also have this number, and you'll also have this number. So this actually has 3 values. You can write them down, okay? So we'll just keep going through. You don't need to do it now. But this one is an inequality, less than or equal to 3 here. So 3 is here, right? So anywhere below 3 there. You see what I did? I had to change that because I was treating this as 0, not 3. So where is your graph? So this is saying where is your graph less than or equal to 3. The value is less than or equal to 3. So that's going to be all of this area here and this number as well. So I'll help you with this one because I think it's quite difficult. Come up to here and here. So it is below 3, between -3 and 2, that's 2, or this value here, because you equal 3 at this point, and that would be 4, x equals 4. So that should be your answer in the answer keys. So this here is where your graph is below 3, okay? I answered that one for you anyway. So you can copy that in your book here and just check my answer in the back. Is that all right? Scroll up a bit. Remember what I said about image? Image is the y value of your function. So this is the y value. So here it's saying that x is -2. So you basically take your -2 and substitute in here, here, and here. So you'll get f minus 2 equals 2 minus 2 squared minus 3 times -2 plus 1. And that will be your answer. This is your image here, your y value. So it's basically what is y when x equals -2. And you do the same for this one here. Right, you want to copy that down? I'll leave a bit of time to write these down, because the rest of the period you can work on these. Okay, evaluate G2 and G minus a half. So this is basically telling you to put the 2 into your function here and into here. Okay, so the first one would be G2. Put 2 into your function. 2 times 2 plus 3, 2 minus 4. And that's your answer there. And do the same for this one, except it's just a fraction. All right. So what did we talk about yesterday? Where the graph, where the value of x, find the value of x where the function does not exist. So if we looked at our question there, remember we talked about the denominator. You can't divide by 0. So you can't divide by 0. So basically what it means is that if this denominator is 0, the graph does not exist there. There's no function. So that means we'd say, therefore, x minus 4 equals 0. So x equals what? And that's your answer here. So if x is this number, there is no graph at that point. And when we do graphing, you'll see that later on. Okay, so we always look at the denominator. If the numerator is 0, no problem. That would be like an x-intercept, which we can use when we're graphing. But the big thing is the denominator. So if this is 0, this will make your function not exist at that point, at that x value. And when we do graphing, we'll see more about that. That will make more sense later on. So in these problems, this one, we've got find g x plus 2 in simplest form. That's telling you to put x plus 2 wherever you see x. Okay, that's all it means. So take whatever's in the bracket here and substitute to x. So basically you'll get 2, let's write x plus 2. So you'll get 2 x plus 2 plus 3. You can finish this yourself. And x plus 2 minus 4. You can have a bracket there if you want. You don't need it. But that x plus 2 is in the question. And then we substitute that into x for each part of your function up here. Okay, I'll let you do D yourself. You can try D. Let's move on. That one, you just make an equation. Let's see if you can do it. Now, question 5, take a look here. We've got a function, fx equals 5x minus 2a, where a is a constant. Okay, a is like 3, 4, 5, minus 6, some number. And it's saying if f10 plus f5 is 55, what is the value of a? So I might wait for you. Can you start this one yourself? Because otherwise I'm gonna end up talking too much. So what I want you to do first, find f10 and find f5, whatever they are, because this is your function here. And that should equal 55. Can I give you a few minutes to try that one? Because this one's a little bit more tricky, because the other ones previously are a bit easier. Can you try that for a minute? And then I'll see if you can tell me the answer. I'll give you, say, 5 minutes. And when you think you have a value for A, by your working, not the answer key, you let me know what you got. So what is A? So start by putting 10 into your function here for X, not A. So I'll start you off. You'll have 5 times 10 minus 2A plus whatever the value is when you have F5. So plus, put 5 into your function. And that should equal 55 here. So it's just an algebra problem. All right, can you find A? I'll give you a minute to do that. That's pretty easy, that one. And I'll wait here. So I'm going to take you through a lot of this. And then hopefully I want to get actually to the next section on domain and range. I might skip through some of these and then we will go into domain range. So at least you've covered things for the worksheet, because I want to send you a worksheet soon, because we're going to miss 2 periods. Anyone got A yet? What do you think? Let me know when you got it. But really, they're just algebra problems, many of them. You don't even have to worry about graphs yet, so don't worry about graphing. We'll cover that later. Any answer yet?
5.
Yeah, 5. So you should get 5. So what do you get? 5 tenths of 50 minus 2a plus 25 minus 2a, 55. So I ended up with 75 minus 4a equals 55. And I ended up with 4a equals 20 and a equals 5. I'm just copying from my answer key because I'm not bothered to do it again. So yeah, you should get a equals 5. And if a is 5, that will make this statement true at the top here, this one here, for that particular function. This is a linear function, actually. So that's actually the graph f(x) equals 5x minus 10. Anyway, okay, so a is 5. Just go down a bit. I'll give you time to do these yourself. I think this one is okay. 10 months. So t equals 10 here. And then you calculate the value for R10. So you can do that yourself, that one. I think that's easy enough. Again, this is another function. According to model, which best approximates the temperature after 4 minutes. So in this case, 4 minutes, m minutes. So m is 4. So you just put 4 into there, okay? So that's P4. Like that, and you calculate, it's multiple choice. I think this is an SAT question. Can't remember where I got it from for that one. So that's straightforward substitution. So this one, you need to check which of these equations matches this set of data. So it's easy enough to start checking. So this one is x cubed plus 3. So we've got y equals x cubed. Here we've got minus 2 plus 3. That would give you minus 8 plus 3, which is minus 5. But here y is minus 3. So this is not the answer. It can't be that one, like that. So that's the y value there. So you put your x value in to your function here. You go through, and these equations need to work for each set. I found one that doesn't work, so I know this can't be the answer. And you need to check which one will be correct for all of the sets of numbers. Okay, that's all you do there for that one. Question 9, yeah, you can do that one easy. So question 10, we need to calculate fx plus 2. So remember what I said, you put this here into your function there. So fx plus 2 will be, that's my food, x plus 2 squared plus 1. Okay, so you do a couple of those for a minute. I'll be back in a second. In question A, you should simplify these. All right, when you've got a quadratic, so simplify that as x squared plus 4x plus 4 plus 1. So x squared plus 4x plus 5, like that. This one, well, you've got fx. So fx is already written here, isn't it? Okay, so then you would just write x squared plus 1 plus, now this is f2. So you need to put 2 into your function here. You'll get 2 squared plus 1. So x squared plus 2 squared is 4 plus 1 is 5, 6, like that. So, yeah, so f2 is basically that, putting the number into the function, then added on to your first part there. Is there any problem with any of these? I think for these are okay. You can try these ones. This is the function divided by 3. So that's basically 6x minus 18 divided by 3 and simplify. Okay, that's it. You can try that yourself. There's another word problem. You can do that yourself. But I wanted to talk about domain and range. Okay, so let me talk about this a little bit. Now, if you have a graph, let's take a look at the definition. The domain of a relation is the set of values that x may have. And the range is the set of a relation is the set of values that y may have. So look at your graph here. It goes up in this direction, up to infinity. So that's going to keep going because it's got an arrow like that. So the set of x values are from where your graph starts, and that's going to go to infinity like that. It will keep going in this direction. Your range is the set of y values. So those are the values that are going up in this direction. So your graph is going up, isn't it, as well? It's going up and it's going to the right as well. So in that case, we could say our domain is x greater than or equal to 3. This is one way to write it. I'm just showing you basic way at the moment. And your range is going from the bottom point up. So that's going to go from 2. The y value is 2, isn't it? So your range is going to be from 2 up. But you should write y because we're talking about range now. So y greater than or equal to 2. And there are other ways to write that. We look at down here. So here's an example. And these are 2 methods for writing the solution. So let's look at this graph. See, your domain is going from this point in this direction to infinity. So it's going to go from -1 here to infinity. I'll talk about this notation in a minute. And then your range is going to go from the lowest value up in this direction. So it's going to go from -3 up. So your graph is going to the right, but it's also going up. So you're going to go from -3 to infinity, positive infinity. And for your domain, we're going from -1 to infinity in this direction. So you're going in this direction to infinity, and you're also going in this direction to infinity. So that's your interval, what they call interval notation. I like this notation better than the set notation below. Now, if you notice here, we've got a square bracket. You see that square bracket? That means you include this number. That number is included. It's a solid dot. So we include -1 and we go up to positive infinity, but infinity is not a number, is it? It will keep going. So we use an open bracket like this, a curve bracket. Okay, so that means we include -1 and we go up to positive infinity this way. And we do the same for range. We go from -3 down here, and we'll go up to infinity in that direction. So from -3 up to infinity. And that just means y is a member of. That's your set notation for member. So that means all y values between -3 and infinity. Now this question here is a quadratic. Now you think about your domain. Your domain here. It's actually going everywhere except this point here. You see it's an open circle. So that's why it's all real x. So we're going from -infinity. That's going down, but it's also going to -infinity this way. Okay, and it's also going down and it will go to positive infinity this way. So that's why it's all real x values, except this point here, because it's an open circle. So except when x equals 2. So your graph could keep going, couldn't it? Because it's got an arrowhead on it. So it's going to go this way. It'll keep going, but it'll also keep going in this direction as well, except this point here, x equals 2, because we use an open circle like that here. There. So we can't include 2 in your answer. And the range goes from -infinity to 1. So it's coming from -infinity going up to here. Because remember, your graph keeps going down and down and down to -infinity. So your graph will come from -infinity, it will come up to 1, and then it will go down again to -infinity. So from -infinity to 1, but we don't include the 1 because of the open circle. That's why it's got an open bracket there like that. Ah, see my error? That should be curve as well. So I've got a mistake there, because remember, -infinity is not a number, so we don't include that. I've got to fix that there. So -infinity up to 1. Your set notation is what I just showed earlier. X such that x is greater than or equal to 1. So that's the same as this one. And y is greater than or equal to -3. That's the same as that one. And same for this one here. But that's something you can look at more yourself a bit later. What's the time? 12:04. Just wondering if I should explain this one. Now, radical functions, let's do a basic idea. Y equals square root x. So radical function involve these root signs here, like these here. These are called radical functions. So I'll include it now because it's something you're going to see quite a bit of. In this case, we can see that the radical is 2. That's this number here. That's the radical. The radicand is the bit under the root sign. Okay, so we think about domain and range. If I was asking you to graph this, what would you do? Apart from crying, don't cry yet. So how are you going to graph this? What would you do? We can get a program and plug it in, but you could choose some X values. So remember, any kind of graph you can make with X, Y. Okay, so you can have -2, -1, 0, 1, 2, 3, like that, up to 4. We'll keep going. And then put them into your equation here, X and Y. Let's think about this very basic graph. So if you put -2 in here, you'll get an error, don't you? That's not a real number. So no value here. Square root -1, cannot. Square root 0 is 0. That one's okay. Square root 1 is 1. Square root 2, you'll need a calculator for that. Square root 2 is root 2. Root 3, and root 4 is 2. And you can keep going. So 0, 0 is our first point here. We've got 1. So the X value is 1, the Y value is 1 here. 2, 3, 4. So I'll make my life easy. When X is 4, Y is 2. So that's here. So your graph is going to go in that direction like that. Smooth it now. Let's draw it again. So it's going to go this way here. So this is Y equals root X. So what's the domain then? Anyone? Keep it simple. Your graph is from 0 going this way, yes? So this will be your domain. Your range is going up. The graph is going up. So it's going this way, isn't it? For your range. So your domain is going to be from 0. We can include 0, no problem, these numbers here. So we can include 0, and then we go to infinity. Right, that's your domain for this graph. For your range is going to go from 0 to infinity in this direction, up. So your range will be, again, from 0 to infinity. So that would be your domain and range for this problem here, for this graph here. Okay, so that's how that's basically working for radical functions. Here's an example here. I drew on the computer. Let's make it a bit smaller. Like that. So this is your function here, y equals root x plus 1. You just choose some numbers. You just make a set of numbers, x and y, and choose some numbers. Obviously, we can have -1, but -2 won't work. -1, 0, 1, 2, 3, like that. Choose a few numbers and then put the y value in. You'll get this graph here going up in this direction like this. They always curve, they look a little bit like a parabola. It's half a parabola, actually. This is half a parabola. We'll do that a bit more on that later. But here we can see your domain. Where is your domain? Your graph is in this area. So follow from the graph, from as far as you can go on the left in this direction. So this is your domain from -1, which is here, until positive infinity here. So that's your domain. How about your range? So your range is looking at the y values. So now we come from here down to the point. So your range, so y is a member of, from 0, because this is your axis, from 0 to infinity there. So your range is from 0 to infinity for the range. So it's just telling, the domain and range just tell you where the graph is and where it's not, okay? So this is your domain again in green, because the graph is going from -1 to infinity. And in yellow, this is your range from 0 to infinity as well. Okay. Oh, rational functions. I think we're going to run out of time. I'm going to leave it at this point, because this takes a bit more to explain. So what you can do, you can go back here and complete some more of these questions, because we only have about 8 minutes left. Okay, so you can go back to exercise 4 and work on these. Okay, you've got your answer key in the back of the book, so you can check there. And then I can write a few solutions in a minute if you want. But go back to question 2. Can you go back there? It's really hard to teach this online because it's not really that easy to teach, actually. So go back to exercise 4 for a minute, and I'll wait for you. Yeah, so if you're doing this one, what did we get? Okay, this one, an f -4. So in this question, just calculate. That's going to be 50 minus 15, isn't it? That's going to be 35 for question 1. And then do the same for -4 here. This one here. I'll clean some of this out. So if you are still stuck, you can keep listening. If you know what you're doing, you can work for a while, okay? But if you are not sure, you keep looking here for 10 minutes. But if you think you know, I'll let you work. So you should listen if you're still not sure about things. So H0, in this case, the X value is 0, isn't it? So if we look at our graph, this is X, 0 is here, this line. So that means we are looking at this value here. So when X is 0, remember this is Hx, you'll get -1. This point is -2 down here. So this is going to be -1. Okay, for that one? Okay with that? Because you'll need to do it on the worksheet. They're very similar. The worksheet's quite similar to this. Let's see, eraser. Okay, so H2. So put 2 for X. That's this point here. Here, that's 2. So go up to your graph, which is here, and then come across. So H2 is equal to 3. That's the Y value. So now we've got H3. So now we go 3. So this is the X value is 3. So we'll go to 3 here. And then we'll go up to the graph here. And then we go across to get the value we want, which is 4. Yeah, okay. So H3 equals 4. So this is really, basically this is your X value on the graph. And this is your Y value, that's your image. That's called the image. So you can imagine the X value looks in the mirror. What do you see? You put in your X value, come back the Y value, the image. So when you look in the mirror, you see your face. That's actually the Y value that you see. You're putting your face into the mirror as X. What comes back is Y. And it's called the input and the output. So X is the input value, and the Y value is the output. That's what comes out after you put it in the function. Like that, input, output. That's probably easy to remember, I think. So when you did B, or if you're doing B, find the values of X, which the function equals 3. So we can see this. We already have one answer here, actually, don't we? There. H what equals 3. So we need to look at our graph here. 3 is here. So you're actually going to get 3 values. So that means X must be, to get 3, either X could be -3, come across to this one. So that's 2. X could be 2. That will also give 3 for an answer. And then come across here, 3, 4. So 4. So you're going to get 3 possible things happen. You got H -3 is 3. H2 is also 3. And H4 is also 3. So X has 3 possible values for that question there. I'm just reading the number from the graph. That's all you need to learn how to do. Now we've got a couple of minutes. 3. You don't have a worksheet yet, but it may be coming in the next couple of days. So if you've got any problem here, you should let me know with any of these. This one, simplify these here, question C. So simplify them as far as possible. Find X if Gx is -3. So in this case, I'll show you this one quickly. It says your function equals -3. This is your function here. So this must equal -3. That's what it's telling here. So we have 2x plus 3 on x -4 equals -3. So this is an equation you need to solve. So just find X for that one. All right, so we did that one already. These ones are just substitution, okay? So you should have no problems with these ones. So it's 250, 4. In this case, T is 10. So 10 on 5 will be 2. And you'll get an answer there. So that's the population size after 10 months. And this could be graphed. This is like an exponential graph, actually. Exponential function, which you do more in grade 11, actually. Not so much with me, but more exponential in grade 11. So that would be like y equal 2 power x. That's an exponential graph. You'll see that later on. And that's another exponential here, but looks different. Okay, I'm going to stop there. It would be a good idea for you to try some of these yourself before you get the worksheet. I may even send the worksheet today. All right, so I'm recording this session so you can go back from the start and look through and then try to finish these in the next couple of days. Okay, I should have let you work on them, but I'm not sure you can actually do these properly yourself yet. So that's why I spent a lot of time talking about it. All right, so I'll see you next week.